In this video, we are going to discuss the last class of lipids that are not hydrolyzable and are not part of the membranes, but they have important functions for the body. This is when we discuss the family of eicosanoids, in which we have prostaglandins, thromboxanes, and leukotrienes. They are all derivatives of arachidonic acid, which is a carboxylic acid that has 4 cis double bonds in positions number 5, number 8, 11, and 14. You guys have access to this in the PowerPoints, but it's important to understand that these are important lipids because they are derived from the arachidonic acid and they have a wide variety of effects in our body. Among other things that they can do, they lower or raise blood pressure, and they can cause inflammation and blood clotting and induce labor. They are behaving as if they are hormones. However, the difference between hormones and the eicosanoids, derivative of arachidonic acid, is that they are hormone-like, but they are not transported in the bloodstream because they are hydrophobic, and they are being used in situ, in the same place where they are synthesized, they are going to be used. We can take some anti-inflammatory drugs that can prevent the synthesis of some of them. You probably have seen that in the PowerPoints that I provide, in which if you have taken any aspirin or any ibuprofen, you are probably inhibiting the synthesis of prostaglandin H2, which is what can cause fever or can cause pain. These substances are made in a hydrophobic environment, and they are being used in that environment by an enzyme that can do the cyclization. That is what is called a peroxidase. Now, I'm going to discuss the same topic by looking at the different derivatives. If we have an arachidonic acid and we can read that it has 20 carbons long, it's a carboxylic acid with 4 6 double bonds, and the position in delta are 5, 8, 11, and 14. 3 different kind of products. If they are prostaglandins, that's one kind, you will always find a 5-member ring with some modification. It could be a ketone, a diol, but still it will always present a 5-member ring. If it is a thromboxane, instead, it's going to have a 6-member ring ether. And if it's a leukotriene, we will see that it's an open chain. The functions are very different, and the mechanism of synthesis of this one we are going to discuss. In this mechanism, we will see that is a free radical mechanism. It's a chain reaction in which we are going to lose the hydrogen that is on position number 13. I will show you that mechanism pretty soon. And in that chain reaction, we are going to use a tyrosine amino acid, and not only that, some iron. The mechanisms that are provided, you guys can take a look at that in the chapter of alkenes. And it's a very complex mechanism, but it's a cascade. You guys know that free radicals are really reactive and they react really fast. The amounts that we will have in our bodies of these hormones are very, very small, but they respond upon a stimuli of any injuries or in diseases. So we're going to look at that mechanism and function. If we can see function of those, they are local hormones. That means that they are synthesized and used in situ. They can produce fever, pain. They also work in the wake-up sleep cycle regulators. If somebody that has asthma, that is actually one of the reactions. If we feel swelling or arthritis, or during the period, the pain and labor, those are all derivatives of the arachidonic acid, and they are all grouped as eicosanoids.